sparse attention in Needle. ND arrays, like we've implemented at class, is very efficient for dense applications. However, for sparse applications, where our matrices can be sparse, like the one you see on the right, it can be extremely memory intensive. Here, sparse matrix implementations can be more efficient, such as for applications like attention, where memory will scale linearly instead of quadratically if implemented correctly. There are three key sparse implementations: coordinate list format, known as COO, where the data corresponds to the columns and the rows. So for example, for this data point 1, it is in column 0, row 0. For data point 2, it's in column 1, row 0, so on and so forth, and finally you can fill in the zeros. Then there's compressed sparse row format. Here the data and the columns are the same, but the row is a little different. For the first row, you take the first two elements of the rows list, and then like you would slice an array in Python, you slice the data array. So from 0 to 3, which is the first three elements, and then you place them in the respective columns in the first row. For the second row, this slice would give you an empty list, and for the third row, you put in the last two. Then you fill in the zeros. There's also CSC, which is compressed sparse column and works for columns instead of rows. Our implementation is CSR because it's easier for row-wise selection for multiplying during attention. We added sparse tensor support to AutoGrad. We created the necessary sparse operations. We tested against dense tensors to ensure accuracy and made an attention pipeline using these sparse tensors.